Hello and welcome back to section 2.4, Graphing Elementary Functions. In this video we're going to be looking at the reciprocal function. Now these functions, the identity function, which gives you the same value back, the squaring function, which is when you put a number in it gets squared each time. We did the absolute value the last time in the last video and the square root in the last video. We're going to do the reciprocal in this video, the cubic ones. These can all be found in the documents folder for week 4 under this handout. So this handout, these are the problems I'm working on in this video, and in the previous video we're working on from this handout right here. So if you want to take a look at this handout, that's where you'd find the functions, the elementary functions that we're working with. Alright, so let's take a look at the reciprocal function now. So the reciprocal function gives you the value of 1 divided by the value that you stick into the function. So if we start off with the negative values, we're going to start off down here. We're going to start with -3. We take the reciprocal, we go 1 over -3, which is going to be -1/3. Okay, we get -1/3 there. And then -2 is going to give us -1/2. Reciprocal, we've flipped the fraction over. This fraction is -2 over 1. We flip it over. -1 is -1. All right, if we graph these first 3 points over at -3, we're going to be down at -1/3. About there. -2, we're at -1/2. -1, we're here. Now we need to figure out, this looks like it's getting closer and closer. If I go -4, it's going to be -1/4. That's going to be a little closer there, and we're going to get closer and closer. We need to figure out what happens over here, because if we try to plug 0 in here, we'll get 1 over 0, and 1 over 0 is undefined. So we can't define that function at 0. So that means we have to kind of skip that value in our table. But I want to see what happens when we get a little closer, like if we get -1/2, what's happening. So -1/2, that means we're going to take the reciprocal of that, which is going to turn this over and make it -2. At that point, -1/2 is going to go to -2 right about here. And if we went -3, we're going to get, I'm sorry, if we went to, we already did -3, if we went to -1/3, we would get the reciprocal of that, which is -3. So our negative values kind of look like this. So our graph is going to travel kind of close to this axis, and it's going to curve down and get close to this axis. We don't have answers for either of those axes. It doesn't cross the axis. Those are what we call the asymptotes for this function. The y-axis, which is x equals 0. Y-axis, it's x equals 0, that's an asymptote, and the x-axis, which is y equals 0, that's an asymptote as well for this function as we travel. Now, if we look at the positive values, we're going to start, if we just look at positive values, they're going to give you the same or similar results. So at 3, we're going to be at 1/3. We take the reciprocal, it's going to be positive. At 2, we're going to get 1/2. At 1, we're going to get 1. At 1/2 here, we're going to take the reciprocal of that and get 2. So on the other side of the axis, it does something similar. At 3, we're at 1/3. At 2, we're at 1/2. At 1, we're at 1. At 1/2, we're at 2. And at 1, if we went to 1/3, we'd be at 3 right there. So we have a similar graph. It travels along this axis, close, 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 and then turns and gets close to the other axis this way. Now it doesn't cross either axis. Those are what we call the asymptotes. It's not defined. It's not defined at 0. It doesn't have a value at 0. And it looks like our function can never equal 0. We can't have 1 over x equaling 0 either. The only time a function or a fraction can be 0 is if the numerator, that's the top part, is equal to 0. And since this is a constant 1, it can never equal 0. So our domain here is going to be everything except 0. We should be able to plug in everything except 0. So that means if we were writing this out in interval notation, we would go negative infinity, and then we end at 0. Oops, we end at 0. And then we would continue on after 0, so we'd have another interval starting at 0 and going to positive infinity. So that would be our domain. We can keep going from negative all the way down to negatives till we hit 0, and then we can't go on. But then we can go from positive, from 0 on. Only the value that doesn't work is 0. Now if we look at this, we have similar answers here. If you look at these answers, they're similar. It can't have 0 there, so the range is the same as the domain. So it's the same exact values for the range, negative infinity to 0 and 0 to infinity. So we have those. That's our domain and range. Now if you look at this, increasing or decreasing, as we travel to the left on the graph, we're going down. We're going down. And as we travel here on the left, we're going down. So it's always decreasing. So it's decreasing on this same interval, and it's never increasing. So we would say it's never increasing. It never goes up. It always travels down. As we travel left on the graph, it's going down. As we travel left on the graph, it goes down. So it never increases, it always decreases. So it's decreasing on the whole domain. So it would be the same exact interval as the domain, because it's always increasing, or it's always decreasing. So negative infinity to 0 and 0 to infinity is where it's decreasing. Alright, so that's looking at the reciprocal function. Now I want you to try some of the other ones that we didn't go through. Look at the worksheet, go through the identity function, the squaring function, the cube function. We'll spend some time on some others later on in the course. And those are your elementary graphs up to this point.